Hi everyone, my name is Allie and I will be helping you with some sequences and series today. So in case during your last math class you were just having one of those bad days and you couldn't stay off of Facebook or whatever webcomic you're reading and you couldn't pay attention in class and didn't quite grasp the information, I'm here to help. So what I'll be helping you with today is geometric series and how you can calculate the sum of a geometric series using some different formulas we have here. So the first case we'll be looking at is a finite geometric series. Now this is a series in which there are a concrete absolute number of n values which you're looking to solve for the sum of. So this number of n values is going to be represented by the term x. Now we have our basic general geometric series formula here, which is defined by a times r to the n minus 1. A is the first term of the series. R is the rate of change within the series, so what number you're multiplying to move from term to term. And then of course we have n minus 1, n being the n term that we're looking at. Now the formula to solve for a finite geometric series is defined as a times the quantity 1 minus r to the x, so to the number of terms that you're looking with, that quantity divided by 1 minus r. So by simply plugging in the numbers that are given to you in the original problem, by plugging them into the equation and solving, you will be able to find the sum of the geometric series. Now don't be afraid if when you're working with this formula you get some crazy fractions at the end, because that's quite common when you're working with such large numbers and summing large terms together. So don't get distressed. Now the second case that we'll be looking at here, which can get a little bit tricky, is the infinite geometric series. Now in this case, the variable x is replaced by an infinity symbol because we're looking at an infinite number of terms, a series that just goes on forever. Now we have the same general formula for a geometric equation here, a times r to the n minus 1. But as you can see, our final formula is different. That's because we don't have an x value to be plugging in as an exponent like we do in the finite series. But because we have the infinity symbol here, the equation can be reduced down to a divided by the quantity 1 minus r. And this formula can be used to find the divergence point, which is the value at which the sum starts to level off. And it's not, it does, of course, grow, but very, very, very slowly. It asymptotically reaches a certain value that it will not pass. So that's the divergence value, which can be found with this equation. However, it's very important to point out that a divergence value can only be found if your rate of change, if the absolute value of that rate of change is less than 1. If the absolute value of r is greater than or equal to 1, your sum will not diverge to a specific value. It will converge, and it will approach either positive or negative infinity, and there is no sum that can be solved for. So, now that you have this basic information, hopefully you can use it to your advantage and apply it to some actual problems and real-life situations. So, happy mathing! Thanks!